Okay, so I'm going to be going through a real life example for what you can use the Sigma Pipe software for. So we'll be doing one of the training modules. This is training module 3, nitrogen orifice and choked flow. So to start off, I'm going to create a new Sigma Pipe project. I can get rid of this, and I'm going to create the fluid source here. It's a nitrogen source at 16 bar gauge, and I'm going to call this training 3 nitrogen. So I'll create a new fluid source. Apparently I've already created it, so that's okay. I can exit without changing it, and the fluid sink as well. This fluid sink is at 3 bar gauge, so I'm going to set that here and call it training 3 sink. Create a new fluid sink. Now we want to set up a pipe system to best represent this system. So we're going to use standard size of 100 DN schedule 40 pipe. So I'll select that off the list, and that fills in your connection internal diameter in your wall. Leave the direction, and I'll leave the default source position, but I'm going to choose my source here. It's training 3 nitrogen, add source. Alright, now we want a straight pipe section. I'll leave that to 1 meter. We also want an orifice, which we go through. And this, we don't know the internal diameter, so I'm going to set it to 15. That's just a guess. Here we're trying to find how big the orifice needs to be to deliver the correct flow, so we're using a sort of guess and check or trial and error technique, and we'll be editing the orifice internal diameter and solving it to find out what the flow rate is to find out the correct orifice size. So to create this system, we're going to have a meter of pipe, then the orifice, another meter of pipe, and then our training 3 sink here. And we can have a look at this system here. We'll zoom in and center on it, and we can solve for it. So this finds a flow rate of 1,382. We can then right click and edit the orifice internal diameter. I need something a bit smaller because the flow rate's too high, and solve for it again, and we find it too low. Anyway, through trial and error, which I've previously done, we find out optimal internal diameter of 12.7 millimeters, which we can confirm by solving, and that's almost exactly 1,000 normal meters cubed per hour. The second question here, does it matter if the back pressure or downstream pressure falls from 3 bar gauge to ambient? So to do this, we want to edit our sink here. Our sink on the left hand side, and ambient, that's 0 bar gauge. I'm going to call it a new name now, training 3 ambient, and modify this fluid sink. We can solve for it again. You can find that the flow rate is exactly the same, so no, it doesn't matter if the back pressure falls down to ambient. Now the third question, at times the main pressure can drop to 12 bar gauge. How much nitrogen will be delivered when this happens? So here we're going to edit the source. We're going to edit the fluid type here, and this is our nitrogen. If the pressure drops down to 12 bar gauge, training 3 nitrogen 12 bar gauge is the name I'm going to give it. Edit this fluid source and then solve. We can see that the flow rate does drop. It drops down from almost 1,000 normal meter cubed per hour down to 764 normal meters cubed an hour. So that's basically a real life example of the things you can sort of solve or simulate using Sigma Pipe.